Yes, that is all you. If I can have you. So what I'd like to start with, just if I could, is just some basic questions I think are really, we've been asking these pretty much this week, like why clay? What's going on? What's the interest? And I'd like to sort of maybe ask you right now in your practice, is this an aesthetic decision? Is this like a change of look and feel that it's driving? Is there environmental concern? What are the concerns that would be driving you towards this material? And happy to. You.
That's okay. Well, yesterday I was really inspired by what Andy Brayman talked about, and that like when you look at a piece of ceramic, what you're looking at is a series of decisions that somebody made along the way to get to that final result. So I think there's just like an inherent quality in ceramic, and going through this process this week and in the past few months, you realize that every piece of ceramic you look at, there's just so much thought that has gone into making it, whether even from a simple brick to, complicated terracotta screen. So I think, being in New York, we see that day in and day out with the brick and the terracotta on the buildings there, and that, it's a part of the, history of human culture, really, like the use of ceramics on a building. We're happy to be part of that.
Yeah, so I think our answer would be a little bit of everything, to be honest. We're always searching for best practices for sustainable materials, the material itself, but then also the company and the backstory behind it. So I think this has been an awesome material, but then also an awesome company to get some insight on. But then I think, back to our project, we see a lot of brick and terracotta across our city and many cities. And so the interest for us is how do we, how can we start to bring some of that complementary material back to our design as we touch, existing buildings or have a lot of infill. And so that complementary material, I think, is huge. And then I think someone else said it, but also not just to have all these glass heavy buildings. There's something beautiful about craft and mass. So yeah, I say that's why terracotta.
Mm-hmm. Yeah, I think that there's a kind of a practical kind of component to it as well, where it is a sustainable material and naturally fire resistant and things like that. That when we're doing tall buildings, that are certainly considerations that we're making that go into that process.
Mm.
Yeah, to me, and I think to us in the office, the biggest challenge, as I also mentioned in the slides, is reducing glass and the increasing the solidity of our buildings, right? And it's interesting to tap into terracotta as a material that, the first skyscrapers were brick and terracotta with the steel frame. And, there was the failures of the people didn't know how to work with that technology. Then when those buildings started to go, the modernism came in, and you all had all the Miesian glass boxes, and we kind of, that set the standard, quote unquote, for what a skyscraper should look like. And what we are trying to do now in our practice is to kind of take that obsession with glass out of the picture and really celebrate the craft and materiality. And every time we try to increase, for this environmental reasons, the amount of solid in our buildings, what we end up always getting is like flat metal, metal panel, and that just becomes there's a limit to what you can do with metal, right? There's a lot of shaping that you can do, but there's a richness and a history of craft that comes with terracotta that is very hard to achieve with metal. And there's a richness and design expression that can come with a material that it's very hard to achieve in metal. So that's, I think, what's really been drawing us to it. How can we take things like brick and terracotta that have a long history of expressive materiality and fold it into the high performance high rises that we're working
on. I'm okay. You can.
You're mic'd up.
There is a question on glazing. Just since you're from Matthew Gilligan on our chat here, is my questions for FXCollaborative. I was wondering if they started to think about how they might introduce glazing to their system. Most of the renders look like they were for an open air screen facade.
If we thought about glazing the system inside?
I think because the seam, it was a.
Not
where-
glazing, not the glazing of the terracotta.
I'm sorry, that's right, that's a.
Oh, okay, got it.
Week,
Was it Matthew, was it?
yeah.
Well, Matthew, you just hit our weak point here, because this is the part that we had struggled the most. We kept debating internally where the enclosure line was, and we wanted to kind of explore this duality of the materiality, and we didn't want to put the terracotta behind glass so that it was a non-interior material. And then, so it ended up being, well, we cannot, at one point we were trying to laminate the glass in between 2 layers of terracotta. Long story short, we kind of thought about the important thing is to have the material expression on the outside, and we move the line of the enclosure inboard. It's hard to see in the renderings, but basically, if you imagine the post that we have, the idea is that those posts have the glass behind it. Right, so that's the same structure. It's a shared structure that supports both the terracotta and the glass. And whether it's the size of the cavity, I think it's adaptable to the system. We thought about the cavity being going from just like a standard rain screen with the flat ones to a double wall, a la, just a cavity wall, to something bigger that you can inhabit the gap. And imagine in a residential building, you could kind of have a balcony that has some of these things in here. So the enclosure line was always meant to be kind of this flexible thing that happens behind it. So you would not, again, turn it into a whole building. And that in the buildings, in the renderings, it looks very much like a screen, because it was hard to convey the idea that this is actually meant to go in a punch in a solid wall. And the idea of having this be solids is so that we can just take a solid building like this one, and these things can just like appear in the windows, and then the rest is like the high insulated solid. Did I get that right, team?
So there's one more question, then I'd like to sort of open it up to also the audience here. So which type of glazes are better for controlled light reflection, white or metallic? I think this is a
White
secret.
versus a metallic.
I mean, at least I think we can answer that.
I think so,
in that
guys
it was
can. Yeah.
So Andy, he actually set up like a light meter and a special cone to project light, and we tested, a dozen different glazes, and the metallic one. So
And what was the reasoning? I mean, maybe it's helpful to sort of, it was just you did then the reflectance was the issue. It was just basic reflectance.
The physics of that are a little beyond. So, I mean, but that was kind of the fun thing about the process is like, we knew we had a limited amount of time, and we also wanted to have some fun.
Yeah.
But we came up with ways to test sort of empirically, with a light sensor or, just with digital tools. And I think maybe we didn't have the final answer, but it actually kind of opens up to further study and further thinking about how to use the material.
Yeah, I think for us, it was really driven by the idea of creating a diffuse light as opposed to like a highly reflective light. We wanted that thing to hit the top of the cone and just completely get bounced back and forth without creating a lot of like noise, visual noise. So it was just, we went with the white after exploring some of the metals that we piggyback some of your research, and went with the white precisely to create that glow as opposed to like the very reflective things. We also didn't want this to look like a dark wall from the inside, right? So the metallics tend to be a bit darker.
Yeah. Helpful. Any questions out in the audience? If not, I have others coming. So here's one, I think a very interesting one from Michael Stacey from the Bartlett in London. Welcome, Michael. He says, I was at Lord's Cricket Ground, London yesterday, watching the test match against South Africa in a stand designed by my friend Jim Eyre, looking at the MCC pavilion. In the 21st century, are we afraid of decorative potential of terracotta? We're a little stumped here. No,
I think that's what we're trying to kind of bring back. I would not call it decorative, but expressive.
Yeah.
Right. One of the things that I wish we had more time to explore was precisely all the things that you could add to terracotta to make the panel itself, just the material without glazing it, how can it be expressive and you can have a richness to it. So I think that to me, if it comes from a rigor of the process of, there's a rule that sets up these things, or there's a material expression that comes out of the craft of it, I think that's definitely something worth exploring.
Yeah. Other thoughts on that? I know, because I think you're talking a lot about accenting
Yeah.
openings and things. I thought your project was very much around that.
Yeah. Yeah, I don't think we're afraid of where that can go as far as ornamentation or decoration. But I would say always like, well, I think what this has provided us is a playground to understand how those artistic moves can impact or enhance some of our studies on high performance skins. And even if it's not an envelope, right? But I think everyone wants to make better performing buildings. And, you know, while other materials and processes are beautiful in their own way, I think there is a lot of potential with kind of the molding and the malleability and kind of that custom angle that terracotta provides. And it seems like through this exploration in Boston Valley that there's great potential for it to even become scalable. And I think that's huge because that can get lost really easily.
Mhm.
So
There are a few technical questions. This one I think is quite interesting. As most terracotta facades are ventilated, what are your thoughts related to integrating terracotta within a curtain wall system? And perhaps this would be helpful to maybe explain a little bit. Would you lose the desired massing, the craft attached to the terracotta? Do you or any of your firms experience integrated curtain wall design with terracotta?
Well, Brandon maybe should take this one. Right here in Buffalo, the Roswell Park Center is integrated terracotta in curtain wall. So the curtain wall is supporting all of that.
Right.
And I think as long as eventually the unitized curtain wall just becomes the subframe for this thing, right? So as long as the units are engineered to support the weight of these things, the material, what we learned in this process is that there's a lot more that we can put on these things than just like the extruded panels, right? That the way that the anchoring can happen, you can have a lot more of that being supported off of curtain wall, and it's still basically just a ventilated rain screen.
Yeah. Other thoughts?
You do a lot of terracotta. Yeah, we do a lot of terracotta. And I think one of the interesting things is, yeah, you can obviously very easily integrate it into curtain wall, and the repetition available in terracotta really lends itself to that, because you can do unitized curtain wall, set up the brackets, set up the same size extrusion, and it can pop into a curtain wall very easily. At the same time, like what you're doing on your project, or we've done this too, is you can then take that terracotta and lay it within a brick cavity wall. So like you can in one building switch from a very modern curtain wall to a very traditional masonry wall and have a similar reading, but then it also gives it like this dual reading where you're seeing the same material used in two totally separate systems.
Okay. There's a few interesting questions tied to birds and the fact that they may find their way onto these very ornate and intricate surfaces. Any thoughts about that? I know in the past there's been a real desire to invite more birds onto our facades, so I'm just wondering a little bit about that.
Well, I guess simply with ours, one of the considerations with the sloped top surface was it doesn't completely deter birds, but I think it helps. And then also kind of the undulation or the raking of the unit also. But I can't say like we were set out to not allow birds. I can't say that.
We ask that question a lot whenever we use terracotta, especially in like shelf. And I think we've had studies done that say if the top angle is tilted at 19 degrees or more, it helps deter at least pigeons from roosting. But it's never a guarantee. It really depends on environmental conditions. And one of the major things you can do is like if there's activity near it. So like being able to span terracotta across glass, if somebody's there and you're able to easily clean that, then it makes it a lot easier to maintain.
Thank you for giving us our answer. Our slopes are 19 degrees or more. No, but that's a great tidbit to know in case I get that question asked. Honestly, one of the things that we were surprised is that even when we rolled it out here today, was just it immediately became a habitat for spiders and bees. which it's a good thing, I think, that there's this habitat and maintenance. We can have a conversation about that. But take that bird analysis and kind of move it to another point. It's like bird strikes in glass buildings are a huge issue. And, we have been struggling with that as a profession, and now there's legislation in New York. So the idea of more solidity to reduce the big expanses of glass, I think helps a lot. And turning this from killers to habitat, there's something nice and poetic about that.
No, that's a great point. One other question, and maybe if people have now thought a little bit more, we'll go into the audience, but I think this is an important one. This whole question of facade life cycles. How important is building facade life cycle becoming? And how is that changing your idea of design specifications?
I would say a lot, right? We want that healthy, long life cycle for facades. And one of the things that we talked a lot about with our brick unit is the fact that it is mortared in to traditionally very long life or long lasting material, and not having to add a bunch of metal and things that kind of deteriorate at a faster rate. So I'm curious to see how that can push through and see more and more of, I guess, all systems starting to speak the same language and have longer life cycles. And the fact that it has a second life to it as well, right? Being able to recycle is a huge part, which it was awesome to see the recycling story while we were here.
Right. Yeah. Any other comments on that work?
Well, I think that the life cycle and the low embodied carbon, right? I think as we saw in the lecture by John, the material pyramid, and we're seeing more in our projects where we're being asked, like, what is the carbon load of the project? And, we're working on projects now where we're going to have to do the embodied carbon calculation for a whole 500-foot tall tower. So bringing more awareness to the conversation, I think is important. Definitely the recyclability. It was interesting to learn in this process. I might have specified a lot of terracotta, but I don't think I've ever hung a piece of terracotta. But it calls the attention to the fact that it's demountable and it's not like super glued in there, right? Well, hopefully it's not super glued in there. But that these things are easily demountable, and then you can just take them and recycle. I think it's a huge component to it.
Yeah. Right. Okay, before we close, are there any questions? Yes. So before you answer that, I will repeat the question because our audience can't hear it. So what did you learn by actually handling the material rather than simply sending it out to have it produced and by a sub, et cetera?
Tolerances.
Yeah.
we are the terracotta tolerances and steel milled aluminum tri-pyramid pieces are not the same. So it is a natural material, and especially in this stage where it's more experimental, there was a lot of interesting surprises. I'm sure Boston Valley has figured out how to not have those things vary that much, but certainly if you're exploring things in terms of the material, and if you're learning things and pushing the envelope of the material, give yourself the room to test to fail.
I think there's it's interesting, the broad range of what you have to do, sitting there with a tiny little hex head screw, putting in their set screws to lock it in for wind loads, but then also just drilling as hard as you can through steel and pounding it into place. It's you realize that it doesn't just take brawn, it doesn't just take fine motor skills, it takes everything to put it together. And you get a sense of accomplishment when you put something physical together that just can't be matched on the computer.
I'd second all of that. And then also just I think the relationship between other trades and how it fits into the full assembly. There's a lot of there's a lot more collaboration there and like challenges. I think it goes back to tolerances, but the anchor holes lining up with steel versus clay, and yeah, just finding out how they work together.
Yeah, I'm jealous from all of you who actually got to go play with Andy on the shop, because in terms of the other part of your questions, like we didn't get to see samples until we showed up here. Right. So I wish we would have had a bit more of that, like a halfway trip maybe next time to just like see what's going on, push it up, what over here.
Sounds like an adjustment in the future to think about. Well, I think thank you so much to this panel, to this group. Let's just give them all